Hello, everyone. Welcome back to Python Challenge for All. Okay, let's see where we were last time.
Okay, lesson 19, function to return factors. We tried to find a list of factors and then define the function to do that. Okay, so let's go to the code. So open ex3 and connect it. Let's see. So here is a kind of one-line definition of function factors, which uses this kind of list comprehension and return it as return value. So for example, here factors 48. Okay, after defining this function, right? Yeah, this will answer the factors of 48. Okay, well, we'll see. Find the count of factors for 1 through 20. Okay, so simple. Maybe we can use this for I in range. Okay, so let's change it. So maybe as so len I maybe factors has factors maybe factors they are okay. This is good enough. Let's run it. Something is wrong. I always do this. Okay, so factors they are. So what's wrong? Factors they. What's wrong? Okay, let's see. Number A has factors. Okay, here I need a closing parenthesis. Okay, so one has one factor. Maybe we should start from 2 in that case, which makes it easier. Factors they are. Okay, 2 has 2 factors. 3 has 2 factors. They are. 9 has 3 factors. Okay, here's maybe we will come back to this later, but we need to notice that only several numbers have only 2 factors, like 2, 3, 5, 7, 11, 13, 17, 19. And you know what we call this? They are prime numbers, okay? They are prime. So we'll come back to this later, okay? Okay, let's continue today's lesson. Continue on to today's lesson. Common divisors and multiples. Do you know this? So find common divisors of 30 and 42. Maybe you're more familiar with the word common factor of 30 and 42. That's why they are kind of interchangeable, I guess. Okay, let's try that. With or without using factors function. Okay, so maybe we'll try using factors function. Can you stop the video and try this? And then later without using factors function. Okay, let's do without first. Okay, so up to 30 and 42. One way is to try, for this case only, for n in range without, okay? One to say the smaller of the two, so it's 30. Okay, if 30, I see, okay. If 30 is divisible by n, and 42 is also divisible by n, then say print n. This will give, let's see, find the common divisors of 30 and 42. I guess. Let's try this. Okay, 1, 2, 3, 6. Seems great, right? 1, 2, 3, 6. Fine. So this is too simple. Maybe we want to make it more general. So let's see, for X and Y. So in that case, this case, X is 30 and Y is 42. And here, what I need to write is maybe smaller of the two. This is more general. Okay, +1. Okay, +1, smaller of the two. Okay, and then write X here and write Y here. And instead of printing, we can prepare an empty list and add L, append N. And then after trying everything, print L. Okay, this will give a more general solution. That's one way, without using divs. How about using factors? Okay, maybe you can try like factors fx equals factors x and fy equals. By the way, do you know that we can write in Python, we can write this way? Y equals factors x, comma, factors y. This is good enough. And then what should I write here? If n in, so factors is a list, comes as a list. So we can use the operator in here to mean that, let's try that first. So suppose the list is not a good name. L2 is, suppose that L2 is say 1, 5, 1, 5, 6. And then let's ask 4 in L2. It will give true, okay? And 5 in L2, false. Okay, so this will give true or false for whether n is in list X. So maybe we can write this way, fy, fx and fy. Then, okay, if you want to clarify, maybe you can use parentheses here. Either way, they are optional. This will make it clearer, right? Okay, so if n in fx and n in fy, then append it to L. Then, okay, let's say that it will print exactly the same result as before. Okay, good. How can you find the greatest common divisor, this GCD? You know greatest common divisor? So it is the greatest factor, greatest common factor. In this case, it's 6. So maybe the easiest way is print L, because they are in incremental order. Maybe we can use this. Okay, so that's how we can decide that's how we can define a function GCD, right? So maybe, by the way, yeah, so maybe we can define a function GCD x and y, comma, and then we can borrow this one. And paste it here and select and tab. This will put adequate indentation, so GCD, and then what we do, So what we need to do is return. If we return L, this will return a function list. Okay. So for example, G3 30, 42 will produce a list of common divisors. So what we need to return exactly is -1. Okay, let's redefine it and let's see the result. In that case, it returns 6, single element, 6, single number. Okay, this is what we want. So using this function, let's find the greatest common divisors of 45 and 63. Before that, please do it with your pen. Yeah, your mathematical ability to find, you know how to do it, right? Maybe you learned it at school. But okay, 45 and 63. Maybe we can just 45 and 63. I hope your result is correct. It's exactly 9, right? 45 is 5 times 9, and 63 is 7 times 9. So 9 is the greatest common divisor. Then, next, find common multiples of 15 and 21. List 5 of them. Okay? It's kind of the same idea. Okay, please do it. Stop the video and please try it yourself. Okay, are you back with me? So it's like, how can you make it? Common multiples of 50. Maybe we can make, we can try by x and y, right? X, y equals, what are they? 15 and 21. too easy, right? Anyway, so we can start actually the max of n, max of the two. Okay, in this case 21, and then maybe +1 up to, so maybe we can use while. Okay, n equals max of x and y, and then while true, we continue it. Let's see. That one way is prepare also an empty box, and then I see. Okay, maybe. Sorry. So let's put it. Let's get it back and paste it here. So starting from, let's try it all the way to 1,000, 10,000. Maybe we will break before going that far. But anyway, so for n in range, if n is divisible by x and n is divisible by y, then L append n. This is good. By the way, we need something to stop. So if length of L is 5 or bigger than 5, break. This is fine. Okay, after break, begin the loop, print L. How about this? Let's try this. Okay, good. So 105, 210, 315. Okay, this seems great, right? The common multiples are start from 105 and multiples of 105. Seems fine. So now you know how to find the common multiple LCM. So how can you define the least common multiple function to find the common multiple, least common multiple LCM? So this is so simple. Okay, if LCM x and y, okay, common. So maybe we can borrow this part. We can copy this part, paste, select, and tab. Okay, this is great. And maybe after breaking, maybe we can return, or we can return. Actually, what we want is the smallest. So this is one way, but actually, we can just return here. And we don't need any of these. The smallest, we will find the least common multiple of x and y. So we don't need this either. So starting from the bigger of the two, if n is divisible by x and also by y, then return n. I think this is good enough. Okay, let's try this. So LCM, say, yeah, this one, 15 and 21. Paste. And then it returns 105. Great. Okay. What is LCM 4563? Okay. Maybe we can try this 4563. Okay. So today's, yeah, as you can see, it's, we all know, 9 times 7 times 5, which is 315, right? Let's check that. 9 times 7 times 5. 315, correct. Okay, so today's point is that we can find common divisors and common multiples easily. Okay, so homework, find GCD of these and also LCM of these. And if you know the good algorithms such as Euclidean algorithm to find GCD, try it by hand and compare it with your result. Okay, hope you liked today's lesson, and I'm sure you will come back. See you then. Bye bye.